Hey, welcome back. In this video, we're concerned with winning and losing conditions. This is one of the last things we're going to handle in this game project. Now, let's take a look at our section plan. Now, we've already checked off the first 5 items on our section plan, and the last 2 are the special effects and winning and losing conditions. And I'd like to switch these last 2 around and handle winning and losing conditions just because this is the last of our gameplay programming logic, and the special effects are cosmetic and more like finishing touches, so we can handle those at the very end. So in this video, we're going to create a game over function so that we know when the game has been either won or lost. And in order to win the game, we're going to need to count the number of towers in the world, because once we've destroyed all of the towers, then we know we have won the game, and if the tank itself gets destroyed, then we can consider that to be the lose condition. So I'm back here in the game mode, and the first thing I'd like to do is create another Blueprint implementable event. We have this start game function, which we can call from C++, but we're implementing its logic in the game mode Blueprint, thanks to Blueprint implementable event. I'd like to create another one of these for losing the game, so I'm going to create a void function called game over. And for this one, I'd like to take a Boolean input parameter called b1game. And of course, this is going to be a Blueprint implementable event because the only thing I'd like to handle with this function is displaying that we've lost or won the game, and that we can do from blueprints. So we have a game over function. Now we need to know when we should call this function. Well, first of all, we know we can call this function when we've lost the game, and that's going to be if the tank has died. So let's go into our actor died function here in ToonTank's GameMode.cpp, and we see that if dead actor is the tank, then we're handling the destruction of the tank, and we're setting the enabled state to false. Another thing we can do here is end the game by simply calling game over, and this Boolean b1 game, we can pass in false for this. So that takes care of losing the game, at least from the C++ side. Now we need to know when we should win the game. Now here in actor died, if the dead actor can be cast to a tower, we know that we've just destroyed a tower. Now this would be the perfect place to update a tower count or a variable of integer type that keeps track of how many towers in the world there currently are. Now, in order to do that, we need a variable to keep track of the number of towers. So we can add a private variable here in the .h file, and I'd like to do that down here. So I'm going to create an int32, and I'm going to call this target towers. Now we can initialize this right off the bat to a value of 0. But we need to update this as the number of towers decreases. And we also need to set this to the number of towers there are in the world. Now, we could hard code this to 4, but what happens when we start adding more towers to our levels? Well, then it gets a little bit more complicated. So what I'd like to do instead is see how many towers in the world there are. Now, I could create a function for this that returns an int32, and this function can find out how many towers there are in the world and return the number. So I'm going to call this function getTargetTowerCount. So let's go ahead and give this function a body in the CPP file. I'm going to go all the way down to the bottom and create the function body, and I can't forget to put the class name before the function name. Now this is going to return an int32, and we need to decide how we're going to find out how many towers there are. Now, there's a function that exists in gameplay statics called getAllActorsOfClass. Here's the documentation. It says find all actors in the world of the specified class. So we need to specify a particular class. Now, this function has 3 inputs. First is a world context object. That one's easy. We know how to handle that. But next we have a T subclass of a actor, and this is called actor class. Now we've seen that functions that require a T subclass of can accept a U class as inputs. And the third parameter is a t-array. It requires a t-array of actor pointers, and this is passed in as a reference, and it's not a const reference, which seems to suggest that this function just might change this input parameter called outActors. Another hint that this is the case is that it's called outActors. It's an out parameter, meaning we pass it in, and then after the function has been called, it has values that have been put into it by the function. So we can think of it as a sort of output for the function. Now it says down here for parameters, actor class is the class of actor to find, must be specified, or result array will be empty. We want to find all of the towers, and outActors is an output array of actors of the specified class. So once we've called this function and passed in an array, when the function has finished, that array will contain pointers to all of the actors in the world of the specified class. So we know that this function requires a world context object. Now, if we're going to be calling this from within the game mode, we can pass in this. Next, we need the T subclass of specifying the A actor, and we know that this can be a uClass pointer. Now, we need to specify the class to find. If we specify A actor, then we'll get a big array filled with pointers to each actor in the world, but we don't need all of the actors, we just need the towers. So we can use A tower static class, which will return us a uClass that represents the A tower C++ class. Now the third parameter is a t-array of A actor pointers. So if we create a local variable of type t-array specifying the A actor pointer in the angle brackets, then we can call uGameplayStatics get all actors of class, passing in those three inputs. And the result of this action will be that our towers array should contain pointers to all towers in our world. Now the t-array is a nice container class, which can contain a number of elements as long as they all share the same type. And this class has quite a great deal of functions that we can use when storing items in a t-array. Now, I'm going to scroll all the way down and show you this function here called num, short for number. And it says returns the number of elements in array. So we can use this function to get the number of elements in our array once we have all of the towers in the world. So if we call towers.num, then we can use this as the return value for our function. And as we saw, we set our return value for this function, which we called getTargetTowerCount, as an int32. We can return the number of elements in our towers array. So I'd like to challenge you to implement this getTargetTowerCount function. So create a local t-array of type A actor. You can call it towers or anything you like. Now use the uGameplayStatics function getAllActors of class and make sure you pass in the correct input parameters. Now after you call this function, your t-array is going to contain pointers to all of the towers in our world. So you can simply return the number of towers using that num function that belongs to the t-array class. So go ahead and pause the video and implement getTargetTowerCount now. Okay, so here's getTargetTowerCount. Now the first thing I'm going to do is create a local t-array specifying a actor pointer as the type of element that this array should store. And I'm going to call this towers. Now I need to call uGameplayStatics, so I need to make sure that that header is included. Now I see that it is, since we're using it in some of our other functions, but it's good to make that check. Next, I can use uGameplayStatics, and I'm going to call getAllActors of class. Now the first input is a world context object. I'm going to pass in this. And next is the T subclass of representing the actor class. And I mentioned that we can use a tower static class, which will return a uClass that represents the tower class. Now, again, it's a good idea to make sure that we're including tower.h, which we are. Now, the third and final parameter is going to be the t-array, and we can pass in towers. So once this function has been called, towers will now contain pointers to all of the towers in the world. In fact, if there exist any objects of a class that derives from towers, we would also get those. So since we have a towers array, we can simply return the number of elements in that array. So I'm going to use a return statement and use towers.num. And now we have a getTargetTowerCount. So this is great. We can use this to initialize our tower count which we called target towers. And we can do that when we start the game. So I'm going to place that here in handle game start. In fact, I'd like it to be the first thing we do. So I'm going to take target towers and set it equal to the return value from get target tower count. Now target towers should be initialized to the number of towers in our world. So this is great, but we need to update this count every time a tower dies, which means we need to go into our actor died function. And here, if we've cast dead actor to a destroyed tower, then after we handle destruction, we should update our target towers variable. So we can say target towers, and we can use the decrement operator. We can use either the post-decrement operator or the pre-decrement operator. Both of these will result in the same action, which is taking target towers and subtracting 1 from it. Now, as soon as we've subtracted 1 from target towers, now we need to check to see if target towers has reached 0. So I'm going to place an if check here to see if target towers has reached 0. Now, as soon as it does, we know that the game should be over. So we can call the game over function, passing in true for B1 game, since we've destroyed all of the towers, and we can consider this a win. Now, let's go ahead and compile our code. Now, back here in the editor, what I'd like to do before we wrap this video up is go into our game mode blueprint. So here's BP Toontank's game mode, and we have this event start game. And what we're doing is creating our start game widget, adding it to the viewport so that we can see that start game countdown timer. So we know that start game is being called, but we also need to implement our game over blueprint implementable event. So I'm going to right click and type in game over, and here's our event game over. And check this out. Notice we have this one game and it's a Boolean. So when we call this function from C++, we're passing in a Boolean value for B1 game. The blueprint event node strips out that lowercase b and places a space between 1 and game as sort of a courtesy for us. Now we're going to create some widgets so that we can see when we've won or lost the game, but we'll do that in a future video. For now, I just want to confirm that this is being called and called correctly. So I can do that with a print string node, and we can print the value based on this Boolean. If I click and drag this Boolean straight into the in-string input, we'll see that there's a convert Boolean to string. This is another convenient conversion node that will convert a Boolean into a string for us, and its functionality is such that it will convert to the word true or false based on the truth value of the Boolean. So why don't we test this out? I'm going to compile and hit play. All right, now I'm ready to try to win the game. Hopefully I don't lose before I can do so. And I've lost the game. And you can see false printed up at the top left of the screen. So we now know that losing the game results in event game over being called with false being passed in. We need to make sure that true is passed in when we win the game. So let's try to kill all of the turrets. So I need to really try not to get hit. Oh, I got hit already. This is pretty challenging. And there we go. And true is printed at the top left of the screen. It only shows up for a few seconds, so you might have missed it. Okay, great. So now we have winning and losing conditions. The next step is to actually show this in the form of a widget on the screen so that we're not relying on the print string node. So in summary, we now have winning and losing conditions. And there's just a few things we need to do to polish this, such as creating widgets that inform the player that they've won or lost the game. We also counted the number of towers using a TArray and the uGameplayStatics function, getAllActorsOfClass. Great job. This game is really coming along. In the next video, we'll create those widgets, and then we're ready to start adding special effects and polishing up our game. I'll see you in the next video.